Dear students, we will be focusing in this module on cohort component method of population projection and also ratio method of population projection. The learning objectives of this module is to acquire skills to project the population of a local by 5-year age groups and sex, and through this it is expected to enhance your abilities in adapting and using the cohort component method to project the total population size as well as the number of males and females for each 5-year age group for a specified future date. The cohort component technique uses the components of demographic change to project the population growth. The technique projects the population by age groups in addition to other demographic attributes such as sex and ethnicity. This projection method is based on the components of demographic change, which includes mainly the births, deaths and migration. As we have seen in the earlier slides about the cohort component method, first equation refers to cohort component summary equation, which is usually denoted as P of t plus n, which is equal to survived population plus births plus net migrants. To project the total population size and the number of males and females by 5-year age groups, we need to find the number of people who survive or are expected to be alive in the future and add to the survived population number the number of births that takes place and the number of net migrants. Among several approaches, the approach described here is very easy to use and requires minimum demographic information. However, there are certain assumptions that are to be considered. When the cohort component method is used as a projection tool, it assumes that the components of demographic change represented by mortality, fertility and migration will remain constant throughout the projection period. As a forecasting tool, planners can alter the vital statistics and migration estimates to reflect their view of the future. It is also important that when making a 10-year projection, it is best to perform in two separate projections. That is, a projection for the first 5 years and then a projection for the next 5 years. The result of the first projection is used to perform the second round of the projection. Using the cohort component method when population projections by age and sexes are needed is very ideal and important, and for instance for 5 years, 10 years or longer periods of time if the projections are required. This projection tool allows planners to examine the future needs of different segments of population, including the needs of children, women in the reproductive years, persons in labor force and the elderly. It also allows planners to project the total size of the population. The results can be used in all aspects of local and regional development plans. There are specific steps that are involved while calculating the cohort component method. Step 1, collecting information. The cohort component method requires information from both the most recent and prior census of the local. We need to collect information on the number of births during the past 10 years. Ideally, information on births should be compiled by the age of the mother so that age-specific fertility rates can be calculated. Step 2 is aging a population into the future. That is, the cohort component method takes each age group of the population and ages it over time using survival rates. The third step is adding births. That is, calculate the number of births that are taking place during the projection interval. By age-specific fertility rates, when you use it, it will help you to estimate the number of births that have taken place. The rates are multiplied by the number of women in their reproductive years, and the results give an annual number of expected births. They are then multiplied by the projection period, usually 5 years, to obtain the total number of births that have taken place in the future. The age-specific fertility rate indicates the probability that a woman in her reproductive years will give birth in a given year. The second equation is focusing on sex ratio. Finding proportion of male births is equal to sex ratio of male ages 0 to 4 divided by sex ratio of females ages 0 to 4 plus 100. Then finding proportion of female births is equal to 1 minus proportion of male births. Once the number of male and female birds have been determined, the results are multiplied by survival rate so as to determine how many babies survive into the future. The third equation refers to surviving population, that is, male birds that survive is equal to male birds into survival rate. The other major segment is to add the net migrants. It can be a positive or negative number. Obtaining the number of net migrants is a two-stage process. First, calculate net migration rates, then multiply these rates by the surveyed population so as to obtain the number of net migrants. Applying the method, in this example, we focus on the assuming that the Ministry of Social Welfare wishes to develop a plan for women's development and craft center in a small district. The goal is to project the number of women for the district for the years given in the example. In the example, we can see that the table refers to the first set of the tables for the projection, that is, projecting the population of females by the year 2005. Column 1 refers to age in the year 2000, then column 2 refers to age in 2005, column 3 refers to census 2000 data, then column 4 refers to survival rates, and column 5 is the surveyed population, that is multiplying the columns 3 and 4. The data clearly depicts the various calculations and the results that comes out across different age groups and while projecting. In this example, a computer spreadsheet program is used because it speed up in multiplying columns information. The first row in column 1 shows the births that have taken place from years 2000 to 2005. The age groups have been aligned so that women ages 20 to 24 in year 2000 will become 25 to 29 years in 2005. This first step is important as it helps to determine where to put the census data that is required for the projection. Next, based on the census data for the year 2000 in the column 3, the census information should be provided for the age groups in column 1. Notice that the first cell is empty in column 3. This is because births will be added that taken place during that projection period. Next, add 5-year survival rates to the table as shown in column 4 and finding the number of females alive in 2005. Once the table has been created and census information and survival rates have been added, it is possible to find out the number of women that survive in the next 5 years. Multiply column 3 by column 4 so as to find out the number of females that will be alive in the year 2005. The results are in column 5. Notice some of the females in each group are no more. Adding the number of birds. Estimating the number of birds taking place during the projection period is a two-stage process. First, calculate age-specific fertility rates. To do this, obtain information on the number of birds by age of mother for a 3-year period around the date of the last census taking. If the number of birds by age of mother is not available, use regional or national age-specific fertility rates. Demographic and Health Service DHS are available for most of the developing countries and they provide age-specific fertility rates. The table 2 presents the data for calculating and adding the number of births. Table 8.2 refers to calculating births. As in the column 1, various broad age groups are given. The column 2 is the number of births that have taken place in 1999. Column 3 refers to the number of births in 2000. Column 4 is births in 2001 and column 5, that is births, is equal to column 2 plus column 3 plus column 4 divided by 3, which gives the average annual births. The annual births total in this example are given. The births during the projection period is equal to annual births multiplied by the projection period, and the female births will refers to the expected births multiplied by 0.49. The number of projected births, which will be equal to 3731 multiplied by survival rate, that refers to 3731 multiplied by 0.9809. Column 1 indicates the age of women in the different age, reproductive years. Column 2 to 4 present the number of births for the 3 years surrounding the last census period. An average was taken of the births prior to calculating a specific fertility rate by adding column 2, 3 and 4 and dividing by 3. Once the average births is obtained, the year 2000 census data is used for women in their reproductive years to calculate a specific fertility rates. To do this, the number of births is divided by the number of women in a given age group. Once the age-specific fertility rates are calculated, they are multiplied by the number of survived women in each age group. The sum of column 9 provides the number of expected annual births. To find the number of expected births for the projection period, the number of annual births were multiplied by the projection interval of 5 years. It was also necessary to find the number of female births. To do this, the number of expected births was multiplied by 0.49. 0.49 is based on the use of equations 8.2 and 8.3. The final steps is to multiply the expected births by a survival rate, which is provided in the table. Next is about estimating net migration. The last part of the projection involves accounting for population movements in and out of the projection area. Two methods of estimating the number of net migrants will be introduced. That is, both methods rely on survival rates and census information. It is important to be familiar with the definitions for migration and net migration prior to attempting these projections. Migrations are movements across political boundaries that are semi-permanent or permanent in nature. Net migration can be defined as the number of in-migrants minus the number of out-migrants divided by the population exposed to the possibility or risk of migration. That is, net migration rate refers to immigrants minus out-migrants by population multiplied by constant k, which is usually 100. Obtaining migration information. The process of obtaining migration information has two approaches, that is, the direct method and indirect measures. In the case of direct method, there is a continuous registration system, that is, individuals report their change in residence immediately to a local government office. Use of census information, for instance, based on census question, where were you living 5 years ago? In this case, planners compare the place of residence with the place of prior residence. In the case of indirect measures, vital statistics or residual method or survival ratio method are widely used. Most planners rely on indirect measures for obtaining migration information. The equation 5 for the residual method is calculated as population of t plus n is equal to population t minus 1 plus births minus deaths plus net migrants. Net migrants is equal to population of t plus n minus population minus of births minus deaths, where population of t plus n is the current population, while population t refers to the last census population. In most cases, planners use survival rate methods to estimate net migration rates. The forward and reverse methods estimate net migration by age and sex. The equation for forward method is mx plus t is equal to ptx plus t minus sp naught x, where mx plus t refers to net migration of persons ages x plus t, x refers to in the age or age group, p naught x refers to population age multiplied by the first census, population of t x plus t refers to population at the next census at age x plus t, s refers to survival rate. The survival rate is multiplied by the prior census population, that is p naught x. The result provides an expected population for the present census method. Subtract the expected population from the present census period, that is pt of x plus t. The difference is assumed to be due to migration. The forward method estimates the number of net migrants at the end of the period and assumes that all migration takes place at the end of the period. All deaths occurs in the community for which the estimates are being prepared, or all deaths are to be considered as non-migrants. One problem is that residents and migrants are moving and dying throughout the period. The reverse method equation refers to m is equal to ptx plus t by s minus p naught x. The reverse method uses a slightly different approach. The terminal population, that is population in the last census, is being revived to the initial census date, thereby estimating the number of persons that would have been alive at the earlier date. Then subtract the expected population from the prior census data. Those persons who cannot be counted for are assumed to be migrants. The reverse method assumes that deaths occur to people after they migrate. The reverse method produces more net migrants. The differences are greatest at the older ages where mortality is highest. Most demographers compute both methods and average the results. The assumptions refers to that both methods of estimating net migration assumes that population change not accounted for by fertility and mortality and is due to migration. Population change not accounted for by fertility and mortality may be due to migration. Let's discuss errors in the census counts. The boundary changes from one census period to the next. Table U8.3 uses the forward method to estimate net migration. This method was selected because its process of estimating migration is easier to understand. Census data, for example, which were collected for 1990 to 2000, as well as information on the number of births that occurred in 1990 to 2000, and 10-year survival rates are used to calculate the estimates of net migration. The table 3 depicts the estimating net migration rates using the forward survival ratio method, and the table clearly gives over different age groups how these different components so as to obtain the results are presented clearly. We need to note that the first two rows in column 4 shows the births that took place from 1990 to 95 and from 1995 to 2000. In column 3, the first survival rate is yes 0 to 5 for children under the age of 5, and the second rate is yes 5 to 10 for children ages 5 to 9. The remaining survival rates are for a 10-year period. Notice how the table is set up for this estimation, that is, ages are put in column 1, 2 to guide the placement of census information. The survival rates in column 3 are multiplied by column 4 to produce an expected population for the year 2000. To determine the number of net migrants, the census 2000 population was subtracted from the expected population of year 2000. To obtain a net migration rate, the number of net migrants in column 7 is divided by the expected population in column 5. Some planners take an average of the expected population and the census data and divide the number of net migrants by the average of the two so as to obtain net migration rates. Of course, this refers to the individual choice of the demographer. The net migration rates in column 8 can be used to estimate the number of migrants that came or left the projection locale. Notice that some of the numbers are also negative. Negative numbers indicate out migration in given age groups. In the later age groups, it can also indicate mortality. Let's discuss in detail the entire projection by using the component method. The projection for females for the year 2005 is provided in table 8.4, which clearly gives that in column 1 the age in 2000, column 2 age 2005, column 3 census of 2000 is used, and the survival rates are presented in column 4, and various age groups are clearly provided. The results are presented. The cohort component population projection method thus follows the process of demographic change and is viewed as a more reliable projection method than those that primarily rely on census data or information that reflects population change. It also provides the type of information needed to plan for services to meet the future demands of different segments of the population. Like most projection tools, there are disadvantages by using the cohort component method. First, it is highly dependent on reliable birth, death and migration data. Thus, it may be difficult to collect the information on these components to apply this tool. Second, it assumes that survival and birth rates and estimates of net migration will remain the same throughout the projection period. In addition, it does not consider the non-demographic factors that influence population growth or decline. Even though problems exist, this method of projections is the most widely used tool by planners since it provides information on the potential growth or decline of a locale by age and sex. Now let's discuss about the ratio method. Ratio estimation uses the known population totals for variables to improve the weighting from sample values to population estimates. It compares the sample estimate of the variable with the population total. The ratio of the sample estimate to its population total is used to adjust the sample estimate for the variable of interest. Ratio estimation is frequently used by the auditors. The auditors use ratio estimation as a method of classical variable sampling. This type of sampling is usually referred to as an estimation sampling. The estimation sampling is used to estimate the actual value of a population characteristic within a range of tolerable misstatement. In audit sampling, the ratio estimation is a ratio of proportion of errors in the sample applied to the population value to estimate total error. This method applies the sample ratio to the entire population. Let's try to understand ratio estimation with the help of an example. Suppose you are auditing a company and you want to audit evidence regarding the accounts receivable. Let's assume that the total accounts receivable of the company are US $50,000. You choose a sample of $10,000 and apply auditing procedures to this sample. As a result of auditing procedures, you find out that there were errors or misstatements of $1,000. This means that your error or misstatement ratio is 10%, that is $1,000 divided by $10,000. With the help of this error or misstatement ratio, you can estimate the value of errors or misstatements in the entire population. For estimating the errors or misstatement in the entire population, you simply have to apply the above ratio to the entire population. As we have assumed that the entire population total is $50,000, your projected error or misstatement for the whole population will be %5,000, that is 50,000 into 10%. $5,000 is the ratio estimation of the errors or misstatements in the entire population. Ratio estimation and estimation sampling are important tools that the auditors can apply in their auditing assignments to gather audit evidence, estimate the amount of errors or misstatements, and to form an audit opinion about the financial statements of an organization to see whether they present true and fair view. Ratio method is applied mainly for projecting the population of small areas within a country for which all inputs required by the component method are not always readily available. The method is also useful in the projection of urban and rural populations. This method is used where an area containing the population to be projected, say a district, is part of a larger or parental area for which projections are available. The small areas should exist in a perfect hierarchical structure, that is where geographic units at each level are mutually exclusive and exhaustive, and they can be aggregated to higher levels culminating in one all-inclusive unit. The main drawback of this method is that it assumes that all the smaller areas will grow at the same rate as the parent area. After the ratio of the district to national population is obtained, assumptions are made on the future values of these ratios. Once the future values of ratios are fixed, the population of the district can be obtained by applying those ratios to the projected national population in respective years. The table depicts clearly that the national population, next district population, then ratio of district to national population, and the projected district population over a period of 2001, 2006, 2011 and 2016, and how the projected district population is expressed in terms of the population sizes. Let's discuss it with another example. The family of methods rests on the assumption that changes in any geographical area are a function of those experienced in, that is successfully, wider areas. Thus, the population of a city is held to be a function of that of the region, which itself is a function of that of the nation, and so on. The requirements for such projections are time series of populations for the areas to be used in the analysis and a forecast or set of forecasts for the largest areas. In ratio methods, the population of the second is plotted against that of the parental area, in the example that is nation. Thus, a curve is fitted to the points thus obtained, and by least squares, correlation, graphical or other methods is extrapolated to intersect the projected value for the parental area at a given forecast date. Clearly, if a range had been given for the parent area forecast, this would have resulted in a range for the region. As depicted in the log scale, the y-axis refers to East Midland region population in thousands, then the England population in millions over a period of time is presented. In the second step down, the process is repeated using data for the study area and the region. Again, the curve is fitted and extrapolated to intersect the derived forecast for the parental area. It does not directly examine the components of population change which are subsumed in the central assumption. That is, there are certain forces at work in nations, regions and subregions which make for patterns and order in the proportionate share which the latter have in the former. Further, it is assumed that these relationships change but slowly over time, as depicted in the log scale in the graphical presentation during the 1951 to 1961, how the population, by considering the various subregions, a population expressed in thousands, and how the relationship has been is clearly seen in the graph. Overall, in this module, we are able to understand the various components method of population projection and how it is relevant by using some of the examples and practically applying these, so that we are able to reasonably understand the techniques that exist and the assumptions that have to be taken while projecting the population, and also of various subgroups that are required, whether it is in terms of districts or states or nations or a particular country, while projecting the population.